halls of knowledge, bold and bright, stands in of a world, a guiding light. With wisdom vast and skills untold, they shape the future, brave and bold. From AI's rise to research call, they train the minds to conquer all. Workshops, FDPs, and learning grad, empowering scholars across the land. Innovation flows in all they do, breaking barriers, forging new. A legacy of growth and cheer, academy in of a world leads the frontier. And love, friendship flows in all they do, breaking barriers, forging new. A legacy of growth and cheer, academy in of a world leads the frontier. Leads the frontier. Leads the frontier. Leads the frontier. In halls of knowledge, bold and bright, stands in of a world, a guiding light. With wisdom vast and skills untold, they shape the future, brave and bold. From AI's rise to research call, they train the minds to conquer all. Workshops, FDPs, and learning grad, empowering scholars across the land. Innovation flows in all they do, breaking barriers, forging new. A legacy of growth and cheer, academy in of a world leads the frontier. And love, friendship flows in all they do, breaking barriers, forging new. A legacy of growth and cheer, academy in of a world leads the frontier. Leads the frontier. Leads the frontier. Leads the frontier.
I'm sure you've heard the news. India made history on the moon. We now celebrate that giant leap every August 23rd. In 2023, Chandrayaan-3 soft landed near the moon's south pole, making India the first to land there and only the fourth nation to land on the moon. From Aryabhata's ancient wisdom to today's Gaganyaan mission, National Space Day honors discovery, innovation, and imagination. Here's to dreaming bigger, inspiring generations to come. I'm sure you've heard the news. India made history on the moon. We now celebrate that giant leap every August 23rd. In 2023, Chandrayaan-3 soft landed near the moon's south pole, making India the first to land there and only the fourth nation to land on the moon. From Aryabhata's ancient wisdom to today's Gaganyaan mission, National Space Day honors discovery, innovation, and imagination. Here's to dreaming bigger, inspiring generations to come.
In halls of knowledge, bold and bright, stands in of a world, a guiding light.
Our expert will join in another 2-3 minutes, so let's just wait for another couple of minutes.
From AI's rise to research call, they train the minds to conquer all. Workshops, FDPs, and learning grad, empowering scholars across the land. Innovation flows in all they do, breaking barriers, forging new. A legacy of growth and cheer, academy in of a world leads the frontier. And love, friendship flows in all they do, breaking barriers, forging new. A legacy of growth and cheer, academy in of a world leads the frontier. Leads the frontier. Leads the frontier. Leads the frontier. In halls of knowledge, bold and bright, stands in of a world, a guiding light. With wisdom vast and skills untold, they shape the future, brave and bold. rise to research call. They train the minds to conquer all. Workshops, FDPs, and learning grad, empowering scholars across the land. Innovation flows in all they do, breaking barriers, forging new. A legacy of growth and cheer. Academy in of a world leads the frontier. And love, friendship flows in all they do, breaking barriers, forging new. A legacy of growth and cheer. Academy in of a world leads the frontier. Leads the frontier. Leads the frontier. Leads the frontier. In halls of knowledge, bold and bright, stands in of a world, a guiding light. With wisdom vast and skills untold, they shape the future, brave and bold. From AI's rise to research call, they train the minds to conquer all. Workshops, FDPs, and learning grad, empowering scholars across the land. Innovation flows in all they do, breaking barriers, forging new. A legacy of growth and cheer. Academy in of a world leads the frontier. And love, friendship flows in all they do, breaking barriers, forging new. A legacy of growth and cheer. Academy in of a world leads the frontier. Leads the frontier. Leads the frontier. Leads the frontier. In halls of knowledge, bold and bright, stands in of a world, a guiding light. With wisdom vast and skills untold, they shape the future, brave and bold. From AI's rise to research call, they train the minds to conquer all. Workshops, FDPs, and learning grad, empowering scholars across the land. Innovation flows in all they do, breaking barriers, forging new. A legacy of growth and cheer. Academy in of a world leads the frontier. And love, friendship flows in all they do, breaking barriers, forging new. A legacy of growth and cheer. Academy in of a world leads the frontier. Leads the frontier. Leads the frontier. Leads the frontier. In halls of knowledge, bold and bright, stands in of a world, a guiding light. With wisdom vast and skills untold, they shape the future, brave and bold. From AI's rise to research call, they train the minds to conquer all. Workshops, FDPs, and learning grad, empowering scholars across the land. Innovation flows in all they do, breaking barriers, forging new. A legacy of growth and cheer. Academy in of a world leads the frontier. And love, friendship flows in all they do, breaking barriers,
Can you hear me now?
forging new. A legacy of growth and
Am I audible?
Yes, sir, you're audible.
I cannot hear Ashwarya.
Okay. Okay.
Yes.
Can you have, okay. Okay, sir, once again, welcome to this and wish you a National Space Day. And on behalf of this National Space Day, we are celebrating this 5-day boot camp. So today is the last day, and our participants are almost 300 people have registered, and it is there like across the globe. There are many people from Nigeria. Different age groups are there. So yeah, and this program is collaborated with Marvix and Skyfi, and also powered by iSTEM event. Okay, so we'll start with the official introduction, then we'll get back to you, sir. Is it okay? Yeah. Shalu, you may
you.
start the session.
Happy National Day to one and all. National Space Day to one and all present over here. Yeah. Of boundless blue and starry grace, a human dream to soar through space. To every wings that find the sky, with courage you teach us with to fly. Good evening to all the budding pilots, engineers, scientists, and space lovers in the audience. Your presence here speaks volume about your dedication to aviation and aerospace. I welcome to all join on day 5 of Aviation and Aerospace Conclave to celebrate Aviation and National Aerospace Day, organized by the Academic Canova World in collaboration with Marvex Sci-Fi Tech and powered by Indian Science Technology and Engineering Facilities MAP. Academic Canova World, it's a hub for research-driven innovation, technical excellence, and intellectual property creation. Founded in 2017 as a YouTube channel for aerospace enthusiasts, it now holds an MSME registered STEM research center organized across India. Recently, Academic Canova World has been declared as India's first private research and innovation hub, which was featured by Republic News and Gujarat Journal. I welcome all the co-member associated today. Dr. Aishwarya Dhara, founder of Academic Canova World, Engineer Pulak Kumar Dhara, Chief Technology Officer and former Assistant Scientist at the Department of Atomic Energy, guides our technological advancement through innovative projects and consultancy. Dr. Arunav Majumdar, Research Advisor, whose innovative approaches navigate the research landscape. Engineer Ponma Kishan, event manager, provides technical support to handle outreach activities, and a warm welcome to Ainde Marvelous, founder of Marvex, a Nigerian aerospace company, for associating with this event. A warm welcome to today's expert, Dr. Kshitij Mall, Director Brahmand Lab and Assistant Professor in Aerospace Engineering at the University of South Alabama, Purdue alumnus. I welcome all of you.
You all will explore cutting edge innovations, engage with industry leaders, and inspire the next generation of aerospace professionals. Let us soar together into the future. For those just joining, kindly ensure you type your name, department, and institute name in the chat box. Let's make this an interactive and insightful experience. I invite Ahinde Marvelous, sir, founder of Marvex, to say a few words.
Okay, good evening, everyone, and happy National Space Day to all Indians. We celebrate with you. We celebrate with you. So, I welcome all our participants for staying with us since day one of the program because today is the grand finale of the boot camp. So, I also appreciate our guest speakers that have been with us since day one till now. We really appreciate your time and efforts. I appreciate Academy World for their support for reaching out to partner with them, collaborate with them for this bootcamp. We really appreciate such the invitation. And thank you for the how the program has been. Thank you for how the success of the program that is concluded today. So thanks to my amiable Dr. Ashwaya Dara for for our vision and our vision and dedication as Ghana space and aerospace entirely. So I appreciate our in person of Priyanka, Shalu, Shali, Mr. Paluak, Dara. Thank you all for being here. And also we are honored to have our guest speaker for today. That is Kshitij Mali. I hope I'm correct, sir. So we welcome you to this session of the program. We really appreciate your presence here. We know that during the course of the program, we learn from you. So we thank you for the effort. So I wish all our participants an amazing experience in today's section of the program. Thank you. And once again, happy National Space Day to all Indians. Thank you.
It's my pleasure to introduce today's guest. Dr. Kshitij Mall is a postdoctoral research associate at Purdue University, specializing in artificial intelligence and trajectory optimization for Moon and Mars missions. With a robust background in astrodynamics from Urban University and over 6 years of Purdue's Rapid Design of Systems lab, he has made significant theoretical contribution, including investing epsilon trig regularization and the uniform trigonometrization method. He also coined the learned equilibrium glide coefficient in hypersonics. An experienced system engineer, Dr. Mall has led international students teams to global victories such as the first prize win at the Mars Society Convention. He has practical experience as an analog astronaut and has contributed to over 40 publications. His expertise span advanced programming, machine learning, and certified skill in MATLAB, satellite toolkit, and spacecraft dynamics, making him a versatile leader in aerospace research and education. Let's give a resounding welcome to Dr. Kshitij Mall, sir. The virtual stage is yours. Thank you, sir.
Once again,
Thank you so
welcome.
much. Yeah, Ashwarya, please go ahead.
Yeah, thank you, sir. Thank you for accepting our invitation and being and celebrating with us this National Space Day. Thank you, sir, once again, and welcome.
Thank you so much, Ashwarya, Priyanka, Shalu, Pulakji, Mavik X team, and others who are joining us. Thank you for the very warm welcome. And like Ashwarya said, I would like to thank the other panelists or the other people who were speaking before me because they were kind enough to let me have this slot. I deliberately wanted to have this not just because this is a weekend at my place, so it's more convenient for me, but also it happens to be the National Space Day of India. So I get the honor to speak on this day. So I'm thankful to all the other people before me who spoke, not on this day, but on the other days. So thanks to all of them. And I know many of them have been ex-Air Force officers whom I really admire from my heart for standing for the nation. And my family sleeps in peace because they are there serving the borders. So very much appreciate all what they do, as well as some of the pilots whom I really look up to. I'm a student pilot myself. So I always see people flying things and then I get inspired to do things like them. And to our friends from Nigeria and other parts of the world, I have had the fortune to have a lot of friends from Africa here back at Purdue, from where I'm coming to this new university, University of South Alabama, where I have just assumed the role of an assistant professor just last week, actually on the Independence Day of India. So there's something with celebrations in India and me doing certain thing. So there has been some pattern. So hope this continues. But I have come here and established a new lab called Brahmand Lab. So I will be talking a bit about that as well as the topic for today, which is, I hope it is interesting enough, is like humans, eventually we want to make them multiplanetary species. That's what so many people want to happen, because at some point there might be some problem on Earth, then we need to know ways to get off here so that we still survive as a species. Otherwise, we are doomed to extinction just like dinosaurs. So that's why the talk today is important in those ways. So I will share my screen. And there are a couple of videos which I've shared with Dr. Dhara as well. So in case it doesn't play at my end, I would request her to play it. So we will pause and we will see those. Let me share, I guess. Are you able to see the deck, the presentation?
Yeah, so can you just play for the full screen, sir?
Yeah, okay. Just can you see the switch? Like I moved from one slide to the other.
No, sir, it's not visible.
Just one moment in that
I
case.
think you have to share the entire screen.
Entire screen, okay. Just Okay, I do see this. Let's just see. Now you would see me like this, and now I guess you should be able to see.
Yeah, yeah, it's
It's
perfect.
moving?
Yeah,
Okay. So yeah, so today's topic is humans to Mars, challenges and solutions. So we want to take humans to this lovely red planet and then see where we can go from there. And these are all baby steps. So of course, there are many people who love to go to the moon first. So there is no one good answer, and I would say um, research regarding moon is also extremely important, because whatever technologies you build, not just for going to the moon, also like we now are building Bharat Antariksh Station, which is our own space station, just like International Space Station. So all those are baby steps or very important steps, so that we can have humans go beyond the realms of Earth's gravity, and then go into microgravity, perform a lot of fun stuff, which is very important, not just for space, but also impacts life here on Earth. So there are things like spin-off technologies. Many people, including myself, we use GPS every day. So that is many thanks to space technology that we are able to use those things back on Earth. So moon research, low Earth orbit research, anything that sends things to space, all are very important, because they all are used eventually to take us to larger destinations, or like further destinations like Mars. So first, I will say a few words about today, about myself, and the lab I was talking about. I just established that and the name and everything, and then a lot of work we do in that lab is also geared towards Moon and Mars exploration. So I will share more about the Mars exploration at first. Um, there was one competition I was a part of, so I will share more to the students who are listening to this, so that you could also do things like that, like you can participate in those competitions, and that way you learn as a team how to do things which could one day go to space. And then a topic called entry, descent, and landing, which is very, I would say, very big challenge for landing humans on Mars and stuff like that. So still, it's a big challenge, and that's why I'm trying to solve it along with some folks here at NASA, and also I'm trying to work with folks back in India to help land things from India as well. And then I will talk about analog astronautics, which is another interesting thing, which we, like me and my team members, have been doing for past many years. And then there is an important concept of systems engineering, which is also very important. So I will share about that. And then eventually I will talk about some of the moon research as well. So that way everyone is happy, the Mars people and the moon people, because nowadays there are a set of people who like one over the other. So first of all, today we are here because today is the National Space Day of India, and India became the first country to land closest to the South Pole of Moon. And then this is no, like, small feat. This is very big feat, because so many nations tried, including some of the top nations, and um, it is just like very hard from orbital mechanics point of view to land things on that side. And why that is very important, why, you might ask a question like, why South Pole and not North Pole? Because I think they have identified more of the water and ice deposits in the South Pole of Moon, and that's why that has become main center. And that's where the US mission, which is called Artemis missions, are planning to send the astronauts back, because where Neil Armstrong landed and such, they were not really close to those ice and water deposits or to the poles of the moon. So that's why this day is extremely important, and every Indian should take it with a pride, as well as my friends from other part of the world. What I see about ISRO and India is like, we do have a concept of Vasudev Kutumbakam, which means the world is one whole big family. We see ourselves as one species, and that's why if we do some technological advancements, we don't keep it just to ourselves. We like to help other nations also grow along with us and share a helping hand. And that's why, even if you see the latest, what India has been doing is the concept of Global South, in which we include nations from Africa as well as South America. So we don't leave other nations behind just because we are making strides and just want to stay in, like, say, top 5, top 6. We also see, like, okay, those who are not right now doing those things, let's share information and get the nice talents from there as well, and then improve them, so that every country has something to offer in terms of human resource or some special mineral or whatever. Like, every country has something beautiful to offer. So we would like to take that and include that as a human effort rather than just one nation effort. So if India does something good, that's good for entire world, I guess, in that way. So that's why today is very important for not just Indians, but for everyone in the world. And then a bit about me is, of course, I've laid down this is a slightly dry and boring slide, but what I would like to say is, like, I was in love with aerospace engineering since age of 15 years. Before that, my parents wanted me to be a medical doctor because my dad is an orthopedic surgeon, a bone specialist. So he wanted me to be somebody like him, like a cardiologist or a brain surgeon or something. But eventually, I identified that my calling is outer space, and I saw Dr. Kalpana Chawla and her team. They rise to space, and then while coming back, they had a very unfortunate accident. So that really changed me. And since then, I've been pursuing my goal of coming to this mystical world of aerospace and engineering. And at an age of 15, I decided I will do a PhD in aerospace engineering from US, from a top university. And I think I went on to that path. You can see I started with a BTech in mechanical engineering, that too in a college not very well known, but now I hope more people know. It's Jagadguru Shri Shivratrishvara College of Technical Engineering in Noida. And it's based in National Capital Region in Noida. And it's a part of Dr. APJ Technical University, which used to be called Uttar Pradesh Technical University. So that's where I was at. And then from there, I applied to different universities, but I was slightly late due to some problem with my passport. So that is destiny. I was not meant to come to US right away. So I joined Infosys Technologies Limited, which is the second best IT firm in India after TCS. So that's where I was, and they provide world-class computer systems engineering training. So I became a part of that for 6 months. And I learned basically what they say is I got a Bachelor of Science in Computer Science. What is done in the US in 4 years, I did it in 6 months. So it was that rigorous. From 8 a.m. to 11 p.m., I was like struggling in the computer labs. And I was learning every day a lot of things, from very basics to very advanced things. So all that helped me, because computer science is very important for engineering as such, because many of the problems we solve are extremely complicated. The equations we have cannot be solved by hands. So that's why you need to rely a bit on computers, and you have to learn how to code. So that all helped me, because as a mechanical engineer, I had very limited computer skills or coding skills. Then I came to the US, and my first choice was Georgia Tech University. Not even, I was never choosing a university, I was choosing lab. And that is how even I would tell the students is, whenever you want to come to a place, you have to select the professor and the lab more than anything else. So I chose Professor Bobby Brown, who is one of the best minds on the planet on entry, descent, landing on Mars. That was the thing that excited me the most about aerospace. And that is one of the biggest challenges. So that's why I wanted to put my brain to that. And I wanted to come to a lab called Space System Design Lab that is located at Georgia Tech. So I just happened to visit there 2 weeks back, finally, after coming to the US. I went there, but there is actually, it's told like there is no, like, Space System Design Lab as one lab. There are a lot of labs that comprise and make that thing. So I was under the impression there is only one lab. So eventually I could not go to Georgia Tech. So I applied to other universities, and I luckily applied to a place where Neil Armstrong also applied when he was young. So I happened to be at Neil Armstrong's alma mater, and also known as the cradle of astronauts, with around 27 astronauts. So that's Purdue University. So that's where I went, and I did my master's and PhD. And very luckily, my PhD advisor, for 1 year I was looking, I couldn't get anyone, but after 1 year, I very luckily get my PhD advisor, who actually came from SSDL Georgia Tech. So I never had to go to Georgia Tech. Georgia Tech came to me, and I did exactly what I came to the US for. So I worked on entry descent landing on Mars for human class payloads. So that is what I will be sharing with you today. Then I found some problem which was in a book that I was following. So for that, I did my PhD in applied math with applications to aerospace. So that's why it became a PhD in aerospace. Then once I was done with it, I went to do a postdoc at Auburn University, and there I went to do something similar to Chandrayaan 2 or Chandrayaan 3 missions for low thrust orbit transfer problems, which is also one slide I will share with you. And that is again very difficult problem when it comes to solving it using even computer. So that is what I was looking at. The only difference between that and the Chandrayaan mission is the mission I was looking at was flying at 20 kilometers altitude, so which is very close to the moon surface. So it was for mapping the moon surface and seeing clearly like what's there. So for more clarity, we were sending those missions. And then finally, I returned back to Purdue, and this time I was not hired for either mechanical or computer systems or aerospace. I was hired for artificial intelligence. So that's another interesting thing and important thing I wanted to tell people is keep upgrading your profiles, because I even now I keep upgrading my profile every 5 years. Technology change, something new comes up. So if you don't keep up to date, you will become outdated, and there will be so many others who will leave you behind because you don't even know what is going on right now. So artificial intelligence, and that too now, the third wave of AI called explainable AI is making strides. So that's what I started to bring, not just to words like mission engineering, which is more so related to military stuff, but I brought it to more civilian world aspects as well, and added it to aerospace engineering. And on the right, if you see, I had fortune to go to IIT Kanpur for 3 months. I worked there in lab called the flight dynamics lab. So I was there, and then under Dr. A.K. Ghosh, I had the fortune to work on some unmanned aerial vehicle stuff. Then I also had the fortune to go to University of Tokyo and Keio University, and I worked on some Japanese space satellites, including Micro Dragon satellite that was among the first Vietnamese satellite of its kind that was being sent to space. So I understood how to work with people from Japan, and that's where I also had the fortune to meet my wife eventually. So you never know how life can shape. So I'm very thankful to these universities and these experiences. And then this is what I'm going to play. If you can hear it, that would be great. If not, I would request Aishwarya to play it from her end. But let me try from my end first. This is about the lab that I have started, and it has a full form, Brahmand, to my friends who are not from India. Brahmand means space or universe. So since a lot of things I'm doing is related to expanding the footprints of humans in the universe, I named it Brahmand. And I always wanted to name things from where I come from. So my name and last name also come from Sanskrit, which is a 5,000 years plus old language. Along with Tamil, there have always been a debate which is more older. So I will not go into that. But Sanskrit is among the two oldest languages. That is how I will put. So this is basically the name based on Sanskrit, and its expansion is broad, broad, aerospace, high speed, mission analysis, and design lab. So all those things will happen in this lab. So let me try to play, and let me just see once. Okay, just a moment. All right.
A proud moment for India indeed. A
I hope you can hear.
Nagpur-born, a Kerala-born girl won Mars mission designed for Western America.
Kshitij and Ashwati, two Indian students, have done their country proud. They beat 32 teams from across the world
in the Designer Mission to Mars contest.
All right. So that
A proud
was
moment.
pretty much the Brahmand lab, and in that I'm trying to do a lot of things. Um, Dr. Dhara, is all like everything was audible?
Yeah,
Yeah.
everything was all.
Great, great. Thank you. So I will switch to introduction to one of the topics that is very close to my heart, and I'm told that the audience is 18 to 24 years old, if I am correct. So I
Yeah.
think all these topics should be good enough for the understanding of the broader audience. So there is this world of trajectory optimization. Basically, if you want to go from point A to point B, what is the best way to do that? And it could be anything, like, you want to go from point A to point B in minimum time. You want to do that with minimum energy consumption, or you want to minimize cost, you want to maximize performance. So it could be anything. So that's why this thing is very important, and this thing is also very useful for missions like sending humans to Mars. So that's why we study this. But then in order to solve this problem, there are two methods, or two different types of methods that have been proposed. Mostly what you see on your left, or the direct methods, these are the most popular ones. And why these became popular is because as soon as computers came into being, then people started relying too much on computers. Like nowadays, how people are relying too much on AI, and whatever, if we have problems, we say, okay, let's chat GPT this thing. So we don't think sometimes like, okay, the chat GPT is also databased and it could be biased and it could give us wrong answers. But we go with it. We go with the flow because we think most likely the answer will be correct. So something like that, like direct methods have been used because they involve use of computers, they are easier to set up and everything. So these are their advantages. Very easy to use and very intuitive. You don't have to think too much. If a problem is given, you just write it down in a mathematical style or like in a coding language. Much easier way than introducing a lot of new things. It's just copying something from English and writing it in a coding language. As simple as that. And then in this, if you have different type of constraints, for example, your vehicle has, like, there is only some heating capacity it can take, or heating load it can take. So there is a heat load constraint, or it should not go and strike the surface, like it should fly above the surface, otherwise there will be crash. So you need to keep flying above the ground. So that is another constraint. So those kind of things it is able to very easily handle. Like you write just one line of code and it's able to take that in, and it takes the information beautifully, and it just gives very nice answers. So for most parts, I would say 99.5% or even 99.9%, it gives very nice answers. But for the remaining 0.5 or 0.1% problems, it has issues like the one shown here. This is the very famous Goddard rocket problem, which is what, if you guys have seen Rocket Boy series, Dr. Vikram Sarabhai, when he was back in the UK, he was trying to solve this problem as well. Is the Goddard rocket problem of flying a rocket to achieve maximum height with minimum fuel, things like that. So here, if you see, everything is great, but at the end, this control is going bonkers. Like it is all over the place. You cannot really fly this thing. It's going up and down so many times. So it needs to be cleaner in order to fly it in a real world scenario. So we use all these fancy, like, don't go by the words. These are just some new fancy words. But at the end of the day, like pseudo-spectral methods are type of direct methods, very popular right now. but then sometimes they give these kind of answers. So that is a problem. Why this happens is because they don't use these necessary conditions of optimality and such. But on the other side, the indirect methods, they are extremely mathematical and complicated and difficult to use because they have all these new things or new terms like Hamiltonian, co-states, you have some Jacobians and whatnot. So at the end of the day, it becomes very complicated. So I took like 44 lectures in order to understand like what these things are doing. But then at the end of the day, you get these very tough equations sometimes. This is like lambda h dot, and I can tell you I just showed a snapshot of it, but this is 5-page long equation. If you go into my thesis, although the format is such that little information is there in 1 page, but even then like 5 pages is a lot of information. So 5-page equation, like one equation, it starts and goes on for 5 pages. So things like that are there in this indirect method. But then you can see the drastic difference. Like I solved it using indirect methods and how clean of a solution I get. So that is what it provides, high resolution solutions. And it also provides important insights because I use things like numerical continuation, which is like I solve intermediate solutions. I never solve the whole problem at first. I solve chunks of the problem and I build the solution over time. So I understand like what's going on with the problem, where it is going. So for that, I developed during my PhD a product which I call uniform trigonometrization method. So as you can see, the name trigonometrization, I use trigonometry, which I learned back in India during my 11th and 12th standards. Simple things like that, I included that to solve extremely complicated problems, which many people fear and run away. So these things, in 1950s, these were popular, but after 1960s, 70s, these vanished or waned out. And these ones took the prime spot. So 1970s, 80s onward, these have been more popular, the direct methods. And with the indirect methods, 3 things have been said time and again. Is like, first of all, you need to, like me, take 44 classes or lectures and understand what's going on with this. So it's extremely complicated. Then sometimes in order to solve the problem, even before solving the problem, you need to know kind of the answer. Like, okay, first it's not having a constraint, then a constraint, then not a constraint, then a constraint. So you need to know this structure or the arcs or the flow, like what will come first and what will come later. So then if you already need to know the answer, then why are you even using this? So that's what people used to say. Then the other thing which I was saying is solving the whole problem is extremely complicated many times because the initial guess, if you give something here, maybe it doesn't converge. Like you might not even get the answer. So you need to know the guess to kind of get the answer. So that is also like tricky. It's very sensitive for many problems. So I created this, you can say kind of black box, although the best part is like the coders or the developers, they can actually see what's going behind the scenes. But still, I tried to make it kind of like a black box for anyone who wants to use indirect methods, not worrying about all these problems. And how I address them is nowadays we have Wolfram Alpha and we have symbolic toolboxes both in MATLAB and Python. So we don't need to remember all these extra things like Hamiltonian, the Lagrangian, the co-state equations and whatnot, the optimal control law and all of that. It can be calculated on the fly. So all these things are automatically calculated when you pose the problem. The other thing is I started using the beauty of trigonometry and I started constraining things. So I never solved for in-between things. You don't have to remember what is, or you don't need to know beforehand what is going on in between. You just need to know what is going, like what is at the first point, initial point, and what is there at the end point. In between everything, trigonometry takes care of it. So for that, I use sine function, cos function, secant penalty functions, some small amount of error. So I never solved the exact problem because exact problem always had some issue. So I solved a nearby problem by introducing very small amount of error. This error is like, 0.000001, very small error. So basically I'm solving the same problem with just very minuscule error. So I used to get the same answer. And instead of solving the whole crazy complex problem, I started solving, like, say for example, you have to solve a 10-second problem. I never solved a 10-second problem. I solved a 0.1-second problem. Then once I got the answer for the 0.1-second problem, I use it to solve the answer for 0.5 second, then for 1 second, then for 2 seconds, then for 5 seconds, then for 10 seconds. So I drove the solution and I got the intermediate solutions, and that's how I got to the answer. So that is easier to do than to solve the whole big thing. Just like eating food, you don't eat everything in one go, right? You take small bites. So something of that sort. So there is this publication that I have, which is published in Journal of Spacecraft and Rockets. So uniform trigonometrization method, you can go and see there. I would encourage the audience to check that out when you get chance. Now, this is a snapshot of what all I have accomplished through uniform trigonometrization method, which I developed during my PhD days. So everything in the blue has been done and dusted, kind of like it has been covered. And then the purple ones are the ones we are still working on. So I'm working on a couple of papers, which is also what I will show at the end. Those two papers, actually, maybe it's not in the slide deck, but there are actually a couple of papers which I have placed in AIAA SciTech in upcoming conference in January. So I'll be going there and presenting on these two, like the remaining purple ones. And then quickly moving on to the mass-based research. So what I showed you about trajectory optimization, that is being used in a lot of my Mars research and also in my moon research. So you will be seeing some of it. So at first you saw times now, they woke me up at 8 a.m. and I was like, okay, I had like a couple of hours sleep or 2 hours sleep. And I get a call from +22, which is Mumbai extension 022. So then I see like, okay, what do they want? And they were actually trying to interview me about this thing where we led India to a gold medal along with the Japanese and the US, and also there is one Australian Indian. So we all worked together on this wonderful concept of making 2 astronauts fly to Mars and come back. So this was not a landing mission, but 501-day mission where 2 astronauts will fly very close to Mars and come back. So even that we considered important. It was supposed to happen in 2018, then in 2021, but it has not happened yet. So they are, I guess, still working on it or planning to do something similar in future. But this was an amazing mission in which we had competition from all over the world, including some very nice teams from Germany, from Netherlands, from Poland, from Russia, from many teams from US, one from India. So we took on all of them and eventually we were the winners. So I still remember those days, and it was around 11 years back on August 9, which is when we won this. So the name of the team is also Team Kanao. Kanao means collaboration. So this was a global collaboration stuff that we did. And similarly, I think we are trying to do right now with friends from Nigeria and from other South African nations, as well as from South America, which you will see in one of the upcoming slides. I'm going to show again how we are going to do the Kanao part, the collaboration part. So that is where I got a lot of inspiration to do more of the stuff that I've been doing, is like taking humans and landing, because this is like a flyby mission. So then I thought like, okay, let's see what all are the existing challenges when we send humans beyond Earth, and especially towards Mars. So there are like communication problems because you are far away and you have to use deep space network DSN, and there are communication blackouts. The fun part is, even when we are doing like simulations on Earth, I have faced problems. Even with communication, sometimes things go off and you cannot communicate with others. It's very sometimes nerve-wracking. So communication is one important thing, but we are facing issues, or humans can face issues. Then radiation is one very like dangerous thing. As soon as you are away from Earth, from the warmth of Motherly Earth, then you don't have a lot of things that save you from dangerous radiation. And that's where we need to take some care. There are Van Allen belts, and there are like some cosmic electric rays and whatnot. So there are also some solar events which are also like, of concern. And then if you are sending humans, you have to send something like environment control and life support system. So that is also very important. Otherwise, humans cannot survive. You need to have certain conditions for humans to live, be it the Bharat Antariksh Station or International Space Station. You will need to have this. So if you go and see the BS or the Bharat Antariksh Station layout, there is, I think, a module specifically for this, ECLSS. Then there is throw mass to Mars, which is like, if you see how we launch things even for Chandrayaan, we use like slingshot and such because we don't have capabilities like SpaceX has to throw things with more thrust. So that's why we have to do other tricks like slingshot. So instead of just directly sending things to the moon, we go and move in circles and increase our orbit in that way. So we have to go around that. Psychological effects are a big thing. Again, in one of the slides, I'm going to show you about analog astronautics, and that is what we study in that are isolation. Like what starts happening to humans as soon as they leave Earth and they are not next to Earth. Many times you cannot even see anything outside. It's just black. So it's very gloomy. It's like almost like you are in a deathbed. So you need to have things that keeps you sane. Physiological effects, if you have seen, even if you see the latest interview by Shubhanshu Shukla, who is the first Indian astronaut to International Space Station. Shucks, as he is called, he also shared about the impacts that happened to his body, including like blood flow to his brain, as well as when he came back, the body reacts very differently. It doesn't even know like what to do. So he couldn't even walk properly as soon as he landed. Although his mind knows like, okay, I have to walk, but somehow the coordination is not there. So you start like simple things like walking also you cannot do. There are other problems like your eyes, they start becoming different. So many astronauts start getting like, they need to have glasses. They cannot see well. So those kind of things start happening. Your muscle, your bones start reducing, they wither away. So that was one of the problems with astronaut Sunita Lan Williams along with the other astronaut who were stranded in space for a long time. And then the thing that I thought I should invest my brain on is entry, descent, and landing, because if you cannot land humans where it is needed to be, and also there is a National Geographic, there is a series called Mars, I think, if I'm saying the name correctly. It's just Mars. So in that, the humans landed 80 kilometers away from their home. So they had to take their rovers as well as like, even if you have to walk, 80 kilometers is a long way. And Mars does not have like fancy roads or, like sidewalks so that you can enjoy and take a stroll. It's more risky. The more you are out, there are more chances for you to die. Just like how we talk about expeditions to Everest, there are so many risks just to climb Everest. You can imagine how difficult it would be on Mars, where humans are not even there. So I started worrying about entry, descent, and landing. And then what is this entry, descent, and landing is you slam the atmosphere of Mars, which is 100 times thinner than that of Earth. And that makes it a challenge because it's not like Moon that there is no air, there is no atmosphere. And it's not like Earth, which is very dense atmosphere. So you cannot do the space shuttle way, you cannot do the Apollo way. You have to do some intermediate way that involves all these choreography of things, and all these have to happen in a sequence. And if you miss any of these sequence, this will crash. Absolutely, it will crash. So that's why when you come in, you enter, you hit the entry interface, um, which is around, I think, 80 to 100 kilometers. Usually, even on Earth, that's the case. So that's where there is a feeble atmosphere. So as soon as you hit the surface, the spacecraft, it starts feeling the atmosphere, and it slowly starts to burn like the surface of the sun. So as much as 1600 degrees Celsius is the temperature at the saturation point. So here you can see like this is the point where it has maximum heat. So all you have to do is you have to enter, and then you have to survive this heating thing. Then once you survive that, you are still very fast. So you slam the rest of the atmosphere, which is more dense. As you go down, the atmosphere become denser. So you have more and more problems as it comes to the structural loads and all. So you have something like G load problem. So G load problem is the structure of the aircraft can only hold so much pressure. Beyond that, it will disintegrate. So that is also a major problem. So once you survive the heat load and the G load, then you deploy the parachutes, and then this is like one of the ways of landing. This is certainly not the case for humans, but this has been the case for Curiosity or Mars 2020 landers. So then you deploy parachutes, you remove your, like the thermal protection system or heat shield separation. Then you have the radar to see your speed, and you have inertial measurement units and such. And also you have a interesting thing, terrain relative navigation, which is what I have in one of my videos at the end, which shows how AI is taking over things. Like, it's so important nowadays. AI is almost in everything. And then you do the back shell separation, which is basically launching the rover. So you do entry, then descent, and then you start the landing, where sometimes you have like the sky crane maneuver. In this, you don't have that one. So you just launch this thing, and it has the, oh, actually, it comes at the end, the sky crane. So here you come, you start landing, but then if you come too close, then the retro rockets will start, like, there will be interaction with the Martian dust, and the pebbles, rocks, and all will start hitting the rover. So that's a problem. So that's why you have this sky crane maneuver. So there is some distance, and you land this thing. So all this has to happen in a sequence. And this is what I think ISRO is also trying to do, along with a rover and a helicopter in Mangalyaan 2 mission. If I'm not wrong, that is the plan. So this is a huge, huge challenge, which I have been listening about since I was in my bachelor's days. So that's why I chose this. And then another interesting part is, if you see the map, and this is like a 2D map of Mars, where we have landed successfully are all in the northern hemisphere and never in the southern hemisphere, because southern hemisphere has more elevation, which means it has more rocky things and more like more higher altitude stuff. So people don't want to land on those things because it's more risky. They want to land in plains. So that's where everything has happened. No action in the southern hemisphere. But why do we care about the southern hemisphere? Is because it is kind of untouched, and it tells a lot about the formation of the solar system and the universe itself. So that's why scientists want to go there, but the engineers say, no, we cannot. So sorry, but thank you. We will just go here, up. And now we also have certain rovers that have landed, but also a helicopter on Mars. So when I go to a conference called IEEE Aerospace Conference, which happens in Montana, so that's where they have an entire session on helicopters on Mars. So it is also becoming a big thing, because helicopters have their own advantage. And why we need these rovers and helicopters is, we don't want humans to be outside in danger. For most times, we want them to be hiding inside in more safety. So that's why helicopters and the rovers, they go and explore on our behalf, and they tell and scout and say, like, okay, these are more safer things to do or not. And then the challenges with all these entry, descent, and landing is, first, I told you about the Martian atmosphere, not thick enough to, it's thick enough to create problems like heat load and G loading, but it's not thick enough to deaccelerate enough. So you will burn, you will break your vehicle, and you will also crash. It doesn't help with anything. And then the Martian surface itself, it is, as like I said, we have not done like a road development, or like, we don't have fancy runways there or anything. So you have to basically land on some crazy terrain. So that's why it's very difficult. And if you land at a wrong location, then you cannot even deploy your solar panels. Then you are done for the day, or for the sol, I would say, in Martian context. So you cannot even open the solar panels. You have no power, no energy. Your mission fails, even after successful landing. Then for testing, since it is not Earth, but it is Mars, then you have to develop a lot of testing, and creating Mars relevant environment is very difficult. But there are some certain companies like SpaceX which have try to play smartly around that. So I will share that as well. And Dr. Dhara, how I am doing on time?
Yes, we have almost came to the margin, but yes, it's fine. So we can good to go with this because these are all informative.
Okay, yeah, sure thing. So I will try to keep it in a highlight mode,
Yeah.
and of course, I will share the slide deck with Dr. Dhara as well, so that she can share with the participants if need be. And also, like you would be able to see it on YouTube wherever you are watching, so you can pause and see these things in detail. But I will just go through the highlight. So there are like the on this slide, what I'm trying to show is like there are a lot of people who have tried to think of ways how to land humans on Mars. And then this way, the HIAD or hypersonic inflatable aerodynamic deaccelerator, that is the NASA Langley way of doing things. Then this ADEPT. So one of my PhD committee advisors, he was the chief technologist of this, Dr. Ethiraj Venkatpati. So he calls this as the Mary Poppins way or the umbrella way of landing on Mars. So this is also drag. This is also drag. You need to have huge drag surfaces, or you can go the previous SpaceX route, which is just fire the rockets in the opposite direction, retro rockets. So supersonic retro propulsion, which was the SpaceX way. And then this was proposed by NASA in the design reference architecture 5.0. So this involves lifting, which is like using Martian atmosphere, which is very, very thin, hard to fly. But now we have helicopters flying there, so anything is possible. And this is what at Purdue or at my lab we were doing at RDSL is the high LBD, which is high lifting bodies. And this is what SpaceX came to know through us, and now they have changed the shape of their rocket from this style to this style, and they call it a Starship. So the Starship that you see, we have at least some contribution towards that. Of course, again, you can see all the information here, but what I wanted to say about HIATS is, again, it's a NASA Langley thing, and you have to deploy very huge inflatables. And these inflatables are like the size of football stadium, and to deploy them is very complicated, but still people have been trying to push for this. So its TRL is 5, I think maybe even more now. And then there is this by my PhD advisor from NASA Ames. So it is actually very interesting that it deploys like an umbrella, and then in the end it lands like this. So it uses the umbrella to even land. So that is, again, like all of these have some pros and cons, including the supersonic retropropulsion, which has a lot of mass because you're using a lot of the fuel in order to land. So all you are doing is like you are using a lot of fuel to fire the retro rockets and land, like how SpaceX lands most of its things. But then in order to carry this much fuel, like every pound you launch to space costs at least $2,000, $3,000. It used to cost even more. But thanks to global collaboration, it has been reduced over time. And thanks to some healthy competition, it is now lower. Otherwise, it used to be $10,000 or so. So imagine like these much, if you launch to space, it will be like billions of dollars just for fuel. But SpaceX has already done this. And that's what I was saying. What they were doing is they were testing this whenever their rockets were coming back. So they were testing it at higher altitudes on Earth, which simulates Martian atmosphere. So if you want to test Martian atmosphere, you have to go way high up in Earth's atmosphere. So that's where they were testing. And they tested 16 times, I think even more now. And then this is again from the NASA mission architecture thing. And this is one which was favored a lot, but its mass was more. So that's why that was a problem. And then the lift it produced was not good enough, that it becomes like subsonic. So basically you have to reduce the speed from 6 kilometer per second to 10 meter per second. So that's a massive change. And at the end, the speed was not becoming 10 meter per second. Whatever I was trying to do, it was still supersonic. So it was still fast. So now what has been happening in the past with all these people trying to solve the problem is always this saw that as a falling problem, and I saw this as a flying problem, because I saw, as most other engineers do, there is something free on Mars is the Martian atmosphere. So you can basically fly there if you have the capabilities. So basically what people did was they will see this, okay, this thing is going to crash. So somehow I have to deploy parachute or airbags or something. And then instead of crashing, I have to do something to stop it. But instead of that, I started looking at the equations of motion, and then I saw this term, and mostly this was the accelerator term, because gamma was always negative. So this whole thing became negative, and this whole thing stayed negative. So this was plus, and that thing, like, this is acceleration. So plus of acceleration is like it's increasing. If you keep gamma negative, it is a problem. So how about you make gamma 0 or positive? 0 can happen if you cruise, and plus can happen if you loft. So I started playing with this flight path angle, like how it flies. So instead of crashing, you can cruise on loft. So then I came up with these coefficients, like the world has ballistic coefficient. I gave them equilibrium glide coefficient and celestial constant. And then I came up with this high loft idea along with my supervisor, Michael Grant. So we have this like entry dive phase where we deal with the heat rate constraint, and then we go towards the G load constraint. So whatever is this red is the heat rate, like there it's active, then the G load is active on the blue. Then we cruise instead of falling down, crashing, because we can fly, we fly. And this is so simple, like, you are just flying straight. So good life. And then we loft at a certain height. So what this enables is, even at the south part of the Mars or the southern hemisphere, where you have like these crazy type of terrain, you can still go fly, and then you can land on some place. So you have more capabilities, and you can steer your thing, like you have more controllability. You can control this thing. The other things are more like rock, you cannot control them. So that's the advantage of doing all of this. And then this thing we actually proposed to NASA Innovative Advanced Concept also, and it was among the top 70 concepts. I couldn't land in the top 16 because they were not very happy with the thing that I'm going to show now is the wings. They said this has been done in the 1960s, and just because of that, they disapproved my idea. But I think it's still very valuable. That the thing that is flying, which a Starship is not doing this, but they have like this kind of shape. And then you deploy these deployable wings. So then you gain some more lift. So that's the idea behind this. So this has been studied at Georgia Tech. And then I took this vehicle from Georgia Tech and I started studying in my problem. And then all these have like, these vehicles have their own constants, the parameters, and also based on like, what problem you are solving. If it is Mars has its own parameters. So all that is important for solving the problem that I'm going to share. So this has the highest controllability, but this has been mostly on the papers, but thanks to SpaceX, this is now becoming a reality. So if we talk in terms of math and not all the words that I've been talking about, so using a software called GPOPS2, which is a direct method solver, I was able to solve my problem. Of course, I have to invest some money to get this software, and it runs only on MATLAB at the moment, not on Python. So that's why I had some limitations, but I was able to use it. And then I solved for a slightly simpler problem with planar flight dynamics and such, not a 3-degree of freedom problem. And then I use exponential atmosphere model instead of Marstrom or such, like more accurate models. But at the end of the day, my idea was to just see like what happens even at a conceptual design phase. So with all of these conditions, I was using these equations of motion and then these parameters. And then I also tried to do an aero capture phase, which is like not directly landing on Mars, but actually coming close to the Martian atmosphere like this actually. And then getting captured means like instead of a hyperbolic speeds, which will just make it fly beyond Mars, I use the atmosphere of Mars to kind of get captured and then get into this orbit. So that is the safer step, like get into this orbit first, then at a safer time, then again come and land. So that was the idea. And this also reduces the speed of like entry speed to 4.4 or 4.5 kilometer per second. So with all these parameters, I solved, and then eventually I got this answer. Now I got this answer back in India. I think I was close to Kolkata. I was in Asansol. when I was solving this problem. So that's where, or maybe I was in Maharashtra, somewhere in India, I was there. And then I magically get this answer, and I was just so happy that, oh, finally, after so many years, like 1.5 years of hard work, I get this answer, which looks very easy on paper, but is very hard to solve. And trajectory looks kind of correct, although it's like too much, like, it doesn't look smooth enough. But when I see the flight path angle, I see there is some problem, because when you see this kind of, like, the red part, this kind of trajectory, the flight path angle should be 0, because it's flying straight, basically. So straight will mean cruise, that will mean 0. But here you see the flight path angle is changing between minus 60 degrees to 0, which does not make sense. Something is going wrong. Then I looked at what I did wrong. Then I find out that I was using book along with that one thing that was proposed by French mathematicians, which involved some polynomials. And in that polynomial, the error is in a polynomial way. So it was never, we were never able to stop it from going beyond 1. It has to be between -1 and 1. But it became 10 to the power 5. Like, it became like gaining values of millions. So that's why it became a huge problem for us. So then I thought, like, what to do. Then I did my PhD, basically, or to fix this thing. So eventually, in my master's, this is my master's result. I got this through GPOPs, and using indirect methods, I'm still trying to solve this problem since last 12 years. And I hope in my new position as a professor, along with my set of students, I will be able to solve this using indirect methods finally. So I have published an article on this in AIAA conference. So you should be able to see this. It's a 20-page article, kind of interesting because it shows a lot more than what is shown here. So you can take a look at it. And then along with this problem, since I have been advancing the indirect methods, as well as I came up with uniform trigonometrization method. Since last 13 years or so, I have been solving one after the other very challenging problems. You can see the set here. The very last one is the one that I've been talking with you about. It has not been solved using the method, uniform trigonometrization method, but I'm still trying to solve these two. But the other ones I have all solved. And this free flying robot problem is a breakthrough problem, because first time I was able to show along with my team that the indirect methods, which are very math heavy, can get you answers which are completely different and much better than the direct methods. So this has never been done in literature. First time we proved it conclusively. So that was a big. And then some of these problems are extremely crazy, like these space shuttle re-entry with 5 active constraints. Like, this can never happen in real world, but I even showed if this happens, then also we have solution. And I use behind the scenes all of these. So there has been a lot of things talking to each other, and then that's how I get my solutions. So that is my framework in MATLAB, but similar framework has been built in Python as well. And then I quickly tell about analog astronautics, which is another thing related to Mars. Is all the fancy stuff I showed is done on computers, but this is something which we do on fields where you can go as a team. There have been teams, even I think from India, which have gone there at this interesting place where there are not more than 100 or 150 people to the closest town called Hanksville. So Hanksville, Utah is a place where this Mars Desert Research Station is located. And it looks like this. It is very much like a place on Mars, be it the geology or be it the isolation, like staying away from humans. We were only like 7 people together. I was leading them in my second mission. First mission, I was doing all this funny stuff. Second mission, I was not doing as much. I was flying drones. So I did this lost analog experiment where I used some of my pilot flying experience, where I used a hood and I had limited visibility, which will happen when there is a Martian storm. You cannot see much. So how do you make your way back to your home safely? So that is what we were trying to do, and we were successful in that. For this also, I've written a paper where you can go and see some of the experiments we have done. And I was actually doing things related to electronics and communication, which is not even my forte. So I learned it by myself. I gained certifications by myself. I gave actually an exam in restroom in Japan, which was conducted by people at Auburn University in US. So it was very interesting. At 8 a.m. in Japan, I'm giving an exam in a restroom with 2 cameras, and I scored full out of full, 35 by 35. But that was fun, learning a new skill of radio license and other stuff, which actually all the astronauts have. So that is another fun thing which I did through this. So this is what I wanted to expose students to, is there is a lot happening in the world. And actually in India, there is some set of my friends from Protoplanet, Dr. Siddharth Pandey and his team have started something called HOPE, which is Himalayan Outpost for Planetary Exploration, I think, which is funded by Mahindra and also backed by ISRO. So that is something which is happening at Ladakh in India. So people can look out for that as well. And then this is another thing which I have been doing in my lab, is systems engineering. This thing is not very prominent in India right now, not taught as much, but I have learned about it, and it's extremely important to know like things interact with one another. And when we design missions to land humans to Mars or to send cargo or such, there are a lot of things that have to be in place and need to be developed in sequence or in parallel. So all that study is also done, but it gets as complicated as this. So this is also something fun which I did with NASA Marshall folks, which are 5 hours away from me here now. Right now I'm in the same state, Alabama, so they are located here as well. And they actually conduct a very fun human exploration rover challenge, which is a new name for moon buggy challenge that they used to do. So that is also fun, and in that a lot of Indian teams also come. And this is another video which I wanted to show you so that you know that AI has been used almost everywhere, including landing on Mars. So this is terrain relative navigation. It takes photos and it checks back the data and it sees what are the good points to land. And then if need be, it just diverts and lands at a safer location because you cannot land here. So and finally, sharing a bit about the moon research. This is what I was telling you when I went for 11 months at Auburn University, again in the same state here, Alabama. I worked with Air Force Research Lab as well as Texas A&M University folks. And I was working on some Chandrayaan 2 type of mission, but this was like, I start with something called a quasi-frozen orbit, which is a fancy name for one of the more stable orbits, which is good from energy standpoint. And from there, I go all the way around and I end up in this blue orbit, which is 20 kilometers altitude, like extremely close. So this is extremely low altitude polar lunar orbit. So it is again around the south pole of moon, but it is only 20 kilometers away. And on the right, you see, this is not like bad. This is actually very good. But this has just too many jumps, which is actually really feasible, which is what is shown here. This red part is like where the fuel is used, where there is thrust. And this is kind of the coasting or the shadow part. So shadow, then thrust, then shadow, thrust, shadow, thrust. So that's why it's like switch on, switch off, switch on, switch off. So there's on, off, on, off, on, off. If you show this to anyone who works in indirect methods, they will either get a heart attack or they might faint, because this is not considered possible to solve. This is just extremely difficult. But we have done all of this now, because thanks to the advancements in symbolic toolbox, as well as some of the other advancements. And then this is another thing, I think my friends from Nigeria, from other parts of the world, who might be actually even involved in this, would be happy to know that there is another mission which I am helping out, which is led by India and also supported by the UK. And right now we are in touch with Japan, JAXA. So this mission Shakti Sat is where we are actually making 12,000 girls, although not 12,000 all have come, because we were surprised to see some countries have only 3 girls in STEM education, which is very shocking to know, and which tells why these things are very important. As you know, Shakti means strength, and that is mostly goes with the women. We have a lot of goddesses back in India which represent strength, be it Durga, be it Kali. So to show like, you know, the woman power and stuff, and to empower them in a right way, not in a wrong way, we crafted this whole mission, which is led by Space Kids India, supported by my team Atmanirbhar, and also like some other folks from Purdue University and others. So we all devised this mission where we go from Earth, and then there are girls who learn about CubeSat education, and then we launch the CubeSat made by them towards the moon, and it goes and does a semi-hard landing on the moon. It is not like a very nice soft landing as is done by Chandrayaan 2 or Chandrayaan 3, I should say, Chandrayaan 3. But this is more of a hard landing. So that is the objective, to make things reach there and make the aspirations of so many girls reach. 108 countries are involved. Basically, the whole of African continent, the whole of South America, a lot of Caribbean nations. So all those nations which are, they are rising in space, or they want more space education, where there is more need, that's where we have projected our thoughts and efforts. So those 108 nations are basically already on board. A lot of students participating in this. And then this is the education side of things. Actually, this number is updated now. I think there are more, like 8,000, 9,000 girl students, and there are around 100 nations already onboarded, 8 more to be onboarded. So we made like 120 lessons in CubeSat technology in 21 modules. And then we are changing the way things are taught to students, including giving them information in an interesting way, having some nice pictures which captures the minds of 14 years to 17 years, although the audience here is 18 to 24. But I think even for them, this book might be very interesting, because even for me, it is very interesting. It has a lot of knowledge and information. We also have videos, which are interesting videos, not the boring ones where somebody is standing and giving a PowerPoint presentation lecture, but more so some more fancy animation, or like, astronauts in space telling about some basic things called demonstrations by NASA and things such as those. So we have some very interesting videos. Then we have some very interesting activities, including one where I paid homage to one of my inspirations, Dr. Homi Baba. We got a cloud chamber experiment, which all these girl kids from around the world did it in less than $5, basically using things that are at home. They saw light disintegrate into electromagnetic, or the spectrum, the Vibgyor, and they have all the light broken down in that way. So they see basically magic. They see cosmic rays, which they have never seen in their life. As such, it's all around. After doing all those activities, they do the quizzes, which are also like interesting enough. And then they learn very interesting topics, like how I shared about systems engineering. At an age of 14, they are learning about these things. They are learning about coding, GMAT. They are learning about Wolfram Alpha. They are learning even about space law, which is important, regulations and such. And not just from the Western point of view, but also from the people from Africa are learning about their own continent. South Americans are learning about their own continent. Indians are learning about India as well. So we have made it very comprehensive. And 8 languages have been used so far. And we are using an India-based learning management system called Zoho. A snapshot of it is here. So that is what. And then 1036-page CubeSat book has been developed. And it has also been shared with InSpace, which is in works of releasing it, I think, on August 28th with all the Indian kids of 9th to 12th standard in NCERT curriculum. We are trying to get it done there as an elective, along with AI, robotics and such. So that is another thing we have been doing. And then eventually the conference paper I was talking about, there are basically 3 papers on this moon mission, which is also very important. We are taking that to Sydney, Australia, for International Astronautical Congress. And we are going to work on this 2-3 weeks on this paper. And then this is coming up in very close to my wife's place, actually, in Yokohama, Japan, is this conference in Kosei, which is on systems engineering. So 1 paper on systems engineering on this. So all this is upcoming. And then some papers in the AIAA SciTech is also has been sent. So I think that's all about what I had to say. I think I took a lot of time, but if anyone has any questions, I'm happy to.
Yes, it was indeed interesting, and we didn't even look at the time. Like, what was it? We are actually I felt like we have entered into the mass. It's more like that.
Oh, okay. Oh, thank you.
I think it's for me more like that. So we have some couple of questions here. The first question that I will take is that many people have said that many students saying that maths are really a scary subject. So
Mhm.
we are currently pursuing aerospace engineering. So
Mhm.
how can I improve my maths? I think,
Oh,
as you have said, you have done some mathematical modeling and you have done PhD in maths and then in aerospace application. I think that's how it came, I guess.
so that's a very good question. And to people, I think I could be a very good, I should say, example of how you should not fear math. So in my case, as you know, we have a very dreaded or very a tough exam in India called IIT JE. So at my time, it was extremely like one of the toughest I think I have faced is the IIT JE period, where in 2005, 2006, they changed the curriculum and they had like one very crazy paper. So in that, there were multiple match the following and so on and so forth. We were not even ready for that. So I used to be very good in physics and chemistry. So I always passed those for ITJ level. I was among like very good scorers in that, akin to those who are actually have gone to IIT Kanpur and Bombay. But always my math, somehow it always disappointed me, even though I thought like I could do good math, but somehow I was not able to do. And over time, I understood that maybe I was trying too hard. And math is all about not rote or not memorizing formulae. It's all about thinking math. So sometimes one you have to show as 2 minus 1, and sometimes one you have to show as half plus half. So that's the beauty about math. Like, what would be my way? If I do half plus half, then it takes me to the answer. Sometimes it's like, okay, now I break this thing into 2 minus 1, then it takes me to the answer. So it's all about thinking, and it's more like a chess type of way. It's like, okay, thinking my moves 5 steps ahead. This will happen, so I have to do this thing now. So it will transform into this. So it's all about thinking. So once you start thinking, I think you will start enjoying it so much more than, okay, now what is the formula for this thing? And I will tell you one another beautiful story. I was always like my PhD advisor, who has a huge influence on my life. He changed me drastically how I think, and he came from Georgia Tech as well, where I wanted to go. So what he told me is like, if you remember the formula, if you show me that you are trying to remember the formula, I will take your points off. And he actually did that in the exam where I said, oh, I forgot the formula. So he took my 5 points off. Um, in the aerospace paper, like we have a PhD qualifier exam, which is again a very tough exam. So in that, he took my 5 points off just because I said, oh, I don't remember the formula. But in the math exam, what I did was I took inspiration from that mistake, and I was given a problem, and somehow, like, because I was learning so many things, so I forgot the formula again. So I was like, okay, what do I do? So I said in the paper I wrote, like, I don't remember the formula. So I'm going to derive the formula here itself. And from the scratch, I actually derived the formula. And I showed it like so. But in that process, I think I missed something, and eventually I got something wrong. But still, I think those guys, like, I at least reached to some answer, and they saw through the thing. That is what they do in US. They don't punish you for remembering things. They punish you if you don't follow the process, like if you don't show the process. So process is very important, because in real world, when you do space missions, there will be a team. You are never alone. You have a lot of team members. Even if you are, for example, in flight dynamics team, there are like 2 or 3 people. You are never alone. So if you make a mistake, there are other people who will see through things.
Yes.
So don't worry about remembering formulae. Try to do it in that way. My first journal paper is in mathematics. Although I failed in IIT couple of times in math, my first journal paper is in Journal of Optimization Theory and Applications. So that is a mathematics thing, and then my PhD is in applied math. So if I can do it, I think anyone can. I'm a failed product of India, but here I'm shining. Somehow I'm shining. I don't know.
Definitely now I think the students whosoever is listening, they will not run away from maths.
Yes, think math. Don't rote math. Think math.
Yeah. So we have some couple of questions. How
Okay.
to low thrust from equifrozen orbit, extremely low altitude polar lunar orbit?
Oh, can you repeat that? Like I didn't get the first part.
Yeah. How to lower the thrust from equifrozen orbit, extremely low altitude polar lunar orbit. I think from polar lunar orbit,
Hmm.
how we can use that low thrust.
Oh, actually, I get. I think what they are trying to say is no, not about lowering the thrust, but actually about the trajectory itself.
Huh.
Um, you are like basically you can switch on and switch off your thrusters while you are doing your trajectory optimization. So you have a thrust which has like certain magnitude, like it is on and off basically. So if it's on, it will be at certain level. If it's off, it is off. So when you were seeing that trajectory, you had like the black lines which are like off, and then red lines which are on. So basically, you are changing the trajectory close to your periapsis, where the most change happens, like most energy efficient changes happen. So you are not changing the magnitude of thrust. You are just cleverly playing with where you switch on and switch off, and how long you switch on and switch off. So that's how you get the trajectory changed from a quasi frozen orbit, which is like a stable orbit, low energy orbit, to low altitude, extremely low altitude polar orbit.
Okay. Okay.
Yes.
In what ways landing of rover can be improved with AI?
In what ways the landing of rover can be improved with AI?
Hmm.
I think one thing is like, as you know, AI world depends a lot on data. So when we do more and more missions, we try to collect more and more data. So the more and more data we have, the more and more mapping we do of Mars or of Moon, then we know like, okay, this is how like this place would be, and based on this kind of situation, I have to make like this call. So in order to make AI more powerful, you have to make the data more powerful.
Yeah.
And for that, you have to collect more and more data. So you have to send more and more missions. So we have not as many missions to Mars as we had to the Moon, but still we are still in the phase of collecting more data. And then there are teams like, for example, Pixel team from India. It's collecting like very nice hyperspectral images of Earth, something like that. People have been trying to do of Moon or Mars. Then you have these orbiters which go around Moon or Mars. That is what collects all these extra data, and that's why the extremely low altitude orbit, that is useful, because that helps you collect more like higher resolution data, so you
Okay.
can do better landing. Yes.
Yeah, actually, one question from my side, like
Okay.
as you have said, to work on this machine learning, we have to work on data. Um, for a layman, if anyone like who is specialized in machine learning and want to work on this something relevant to this mission predictions or optimization technique, so they will not have data, right? So how they can work on certain like this kind of mission and all.
So you are saying like when or the
For
data is not
example,
collected.
myself. Okay, I'm more inclination towards machine learning, so I'm working on different projects, and I'm also like working in NASA. Recently, they have given one project something relevant to this. So actually, I was more keen, but I was like hunting for the data because we can only do machine learning when we have data, sufficient data. So what we can do in that kind of cases?
That is again a very good question. I think like some you have to, of course, like for example, the surface mapping of Mars, that you will have to somehow get from somewhere. Unfortunately, like many countries keep it proprietary and not release for
Yes.
one reason or the other. But luckily, India has had the Mangalyaan mission, so they have, I think, some data related to Mars. But I think more missions would help. But apart from that, like if it's related to trajectory side of things, then and not the like mapping the surface, because mapping the surface you need to know
Yeah.
that you cannot like just what should I say, that for that also I think there is an idea to get around that situation. But for trajectory, actually you can do it on computer itself, like how I have done. For simpler parts, you can of course have, like for example, exponential atmosphere instead of mass gram, which is a data collected by NASA folks. uh, but for these uh, the actual surface of Mars, what you can do is like, basically it should be, if it's able to capture like what kind of obstacle it is, and if even from earth you can have something like, if it is this kind of surface, then what do you do about it? So at least there will be some intelligence to decision making,
Yeah.
than to having no intelligence at all and not knowing what to do. Like, okay, now crater came, what to do? Because if you know, there is an interesting story around Neil Armstrong.
Okay.
So he was trying to land, and then everything is looking good, and basically the spacecraft is going all by itself. But then he realizes that the spacecraft, for some reason, is going towards a huge crater, huge or at least a good sized crater. So if it lands there, that's a problem, because then it might land and it might like, and if it tips there, it's just so heavy, like two astronauts cannot like, even with the moon's gravity, they cannot like push it back. So basically they will die. So then, as but because he was very like, he has done so many missions and he was always present while flying. So then he saw that there is a crater. Then he overtook like manual controls. He did a manual override, and then he flew it, and he saw the place, and then he landed. And I think there were only few seconds of fuel left. So to have that much calm, right? Even here on earth, many people will like start shaking, like, oh, now what to do? Only 47 people left, and I'm going in a pit, and what to do? But he's like, okay, so let's take care of this, and okay, we landed. So that was very special about him. In crazy situations when people, even astronauts, are getting heart attack, he's like, okay, so we are spinning like this, let's stop this thing, and we are fine. So he was like that.
Yeah, I think the space missions requires a lot of patience, like lot of, as you have said, like when we are sending, you said around 501 mission,
Yeah,
like
yeah.
there's only mission that from Earth it will just go around the
Mars and back.
and it will come back, right?
Right.
So, and you said there are a lot of communication logs were also happening. So the people like us, layman without train, will be just have a huge heart attack.
Yeah, huge heart attack, like what's going on. So yeah, it requires a lot of patience, as well as it requires survival skills. So many people ask me like, what people need to have to become astronaut? One main thing is survival skills. Like all the time, think you are going to die. Anything can happen, like some fire, okay, what do I do? Some people, you got something, okay, what do I do? So your mind should all the time. That's why Air Force pilots were sent at first from India, is because it's like their bread and butter.
Yeah,
All the time they fly things, they are exposed to a lot of G forces,
G forces.
and all the time they keep thinking like, my craft can go anytime down, so what do I do about it? So survival skills are extremely important.
Yeah. Okay. So we'll take a last question, I think, in this chat box. Shall we use it for safe landing using the parallelogram defense RCNN concept? Shall we use it for safe landing using the parallelogram defense RCNN concept?
I am not completely aware about this concept, what it
RCNN
is.
concept, yeah.
Yeah, I am not.
RCNN concept.
RCN, yeah, I know that. I know about CNN, and then there is dense CNN or dense NNN kind of things. So I'm pretty sure like all these, a lot of new fancy AI world concepts have been,
I
and
think
actually
daily some new concepts are coming. If you go through this einstatic.com, daily some innovative concepts are coming. Yeah.
exactly. And I was saying like every 5 years technology change. Um, I have had the fortune to work with some others on a DARPA project, which was related to more of warfare side of things. But then we were playing games. Actually, that was the joke. Like I play games for a living, so that was happening for some time. And then we were paid to actually analyze games and take the snapshots of those games, and then run it through a CNN with a dense model, and that had like some picture information as well as some text and number information or geographical information and such. So that we had to develop a new type of CNN model for that. So I remember like one of my friends, he is very well versed in that. I'm not an expert in AI, but I do know some about explainable AI, which is what I was hired for, and I was doing things for which I use some tool called SHAP, which is what I would tell the audience to look at. There is a tool called SHAP, So that is an amazing tool made by Microsoft people. So whatever was shared, like the parallelogram, RCNN or whatever. So I'm pretty sure like there are advanced things, and there might be even more advanced ones which would be in the making. All those, as long as they do the job, and they have to be tested before. So if they are proving to be good in the test, as they are safe enough or whatever, they can be taken to Mars and beyond. And sometimes it's a leap of faith. Like some of the technologies, it's like, okay, now we are out of options, so we have to first time test if it works, otherwise.
Okay. Thank you so much, sir, for your time, and also to giving a brief outline about this Mars in human in Mars. So I think there are many aspirants. There are some students who has joined from Dhun School, Uttarakhand. So I think they are really appreciating, and there are some people who is looking for collaboration, doing a research with you. So you just can tell some few words. They are looking for some research collaboration. Whether they can do it as per the norms for your university. Can you do it, sir?
Yeah, thing is, like, I already have how many? 5 students. Of course, I'm always looking for opportunities to help. And as you saw, like, I made that book, CubeSat book, along with my friends to impart education. So I do on the side a lot of things. My university does allow me to do research with other people, including not from the US or from this university. But the only condition they have is like that should not impact my like teaching duties or research duties. So already I would say like right now I showed you like few papers. So I'm already doing few things, but as time permits, I'm always happy to help people out and do research on interesting things in Brahmand lab. That's how why I created it.
Okay, definitely. So, sir or ma'am, you can drop him into, you can connect him through LinkedIn. I guess that will be fine. And if he's free and available, he will definitely get back to you for that. Okay. So, thank you once again, sir, for your time and wonderful presentation. I request Maverick to say a few words, the ending note. Yeah.
Wow, wow, wow. So it's such an amazing section, sir. We really appreciate your time and efforts and your achievements also. We really appreciate it because it's such an inspiring one. It's such an inspiring one because to hold a doctorate a doctorate degree in aerospace is not easy. It's not easy. Even I can remember doing my undergraduate when I studied because I'm also an aerospace engineering by profession. So I'm here to do my master. I've already finished with. I'm done with my first degree in aerospace engineering. I know how it looked like. I know how it looked like. And you holding a doctorate degree in aerospace. I know how the challenge may be because some of the charts you show us, some of the results you show us, it's not something that is easy like that. Sometimes, if you try to solve a problem, you'll be sometimes you won't feel like crying, but it's not always easy. It's not always easy. But thank you for your time and thank you for inspiring us because there are still a lot of us outside there that they are looking for someone that will motivate them to to further more in their academics. So thank you for your time. Thank you for taking us through the stages and steps, in achieving such things. So thank you, sir. I've already sent an connection request to you on LinkedIn, so I still have more to discuss with you. So thank you for your time and thanks to all our participants for their time because this is 1 hour 41 minutes. So thank you all for staying with us. Thank you all for staying with us. Thank you. We really appreciate your time and effort. Thank you once again, Doctor Sir. I don't know if I should call you a doctor or professor.
I go by actually a doctor because my dad wanted me to be a doctor, medical doctor. But I changed my way. I told him one day I will be a doctor, but then I did not tell him which one. So I cannot prescribe medicine, but I can tell a few words of philosophy. So, doctor of philosophy.
Yeah. Thank you, Doctor Sir. We really appreciate your time and efforts. We really appreciate. Thank you, thank you, thank you. Thanks to InnovaWorld for bringing him on board. We really appreciate this section of the program is such inspireful. Thank you. We really appreciate your time. So thank you.
Yeah.
Once again, my name is ID Marvelous. I'm the founder of Mavics. My name is Aine
Marvel.
Marvelous. I'm the founder of Mavics. So yeah, thank you.
Yeah, thank you. And I know that one more time we should congratulate you for this Shakti Sat. And I think the inspiration behind it is Space Kids India, Dr. Srimati Keshan. She is really admire her, and I should have called her, but anyways, we'll talk to her in person some other time. And she's really, you and him is really doing great job. Congratulations to the entire women. I think 4,000 you have said, and around
Even more now. Yes.
yeah. So congratulations to the entire team, sir.
Oh, thank you so much. I'll take the message back to them, and I think they will be able to see this video as well, so they'll
Okay.
feel very happy. But yeah, they have been doing a lot of hard work, and
Yeah.
we are like very. It's like when you start these things, it is all on paper and such.
Yeah.
But when you see actually a girl in Colombia watching the astrodynamics in Spanish, and like this and carefully, then you are like blown apart. Like, what have you just done? At age
Exactly.
of 14, they are watching astrodynamics in Spanish. And the girls in like Nigeria and so many like African nations who like some girls, they are going to just one computer system. Like the whole school goes to one computer system to just learn. So their desire to learn and to become big is so like inspiring for all of us also. Like we have so much privilege. I'm sitting here in high speed internet and all that. There are some girls who don't even have internet. We are
True.
giving them books. We are printing and giving them books so that they can learn. So that is inspirational for us also back. Like, okay, there are people who want to do so much, then why can't we?
Yeah. So let us know in future if any ways we can contribute or we can gather up in some mission. We'll be definitely there because World Space Week is coming soon. So we must celebrate in a grand way.
I saw the hand raised by.
Yeah. Yeah. Marvelous.
Yeah,
Yeah.
yeah. Actually, I don't know that you also know Dr. Kezan, Dr. Shirimati
Patient.
Kezan.
Yeah.
Wow, wow, that's great. That's great. That's great. So yeah, thank you for your time once again. And as regarding the collaboration, I mean the your project that you are doing for ladies, I mean girls. How do you? I don't know. Maybe I'll still chat you up. I'll message you on out since I've been doing as regarding this. Thank you for your time because maybe I might see some people, some girls that are interested from here in Nigeria, so they want to join the program so that
Yeah,
I
definitely.
will bring them on board. You understand?
The more the
So
merrier.
thank you for the time. Thank you.
Definitely. Thank you. Thank you for checking.
Thank you, sir. Thank you for your time. Okay. Thank you, sir. And
Yeah,
thank
thank
you
you
all
so
the
much.
participants. Yeah. Yes, sir.
Thank you so much again to all the participants, all of you for inviting me, having me, and bearing with me so long. I did not know how much time I took because I'm in a different time zone as well. So thank you.
It was really exciting. And dear participants, I think the feedback link is already live in the chat box. So, you know, that's very, very important to get your certificate. I think already the registered email ID that you're registering and filling up the form, you can go back and check your mail. Already you have received the certificate instantly. So don't delay if you've still not filled the feedback form. So please do it immediate basis. So thank you once again, sir. Thank you. Once again, National Space Day, sir. Jai Hind. Yeah. So thank you all the participants.
Jade.
Yeah.
Hope I got the information. Jade. I'll still come to India to come and learn your language.
Yeah, you should come back to India once and visit here. Yeah. Thank you, Shalu. Thank you, Priyanka. Thank you, my entire crew members. Thank you once again, our expert, for being with us, and also the collaborator persons like Marvelous, Mavericks, founder of Mavericks. So, thank you, all the participants, for being with us. And I hope you have definitely learned a lot from it from the day one to day five. And furthermore, if you have any doubts, you can connect him through LinkedIn. He will definitely, whenever he has a free time, he will reach you out. Okay, so we are signing off. Good night from India.
Thank you so much, sir, for your time. Thank you, ma'am.
Thank
Thank
you.
you. Thank
Thank you,
you.
Jai Hind.
Thank you, sir.
Yeah.
Thank you, ma'am.
Thank you, sir.
Hello, doctor. Are you still there? Hello, are you still there?